Hello students, this is Miss Dalton and this is video 9.3, Rational Functions, Wholes. The technical name for a whole is called a point of discontinuity. A graph is said to have a whole or a point of discontinuity at x equals a if the original function is undefined for x equals a. That's going to happen when the value a creates a denominator in the original function of 0, because again, remember, we cannot divide something by 0, so that's called undefined when that happens. The related rational expression in simplified form is defined for x equals a. So what's going to happen is you're going to factor everything, and let's say when you're done, you have these factors that cancel. Well, in the original related or rational expression, that value would have made a denominator equal to 0. But now in the simplified form, it doesn't make the denominator equal to 0, so that's when we have what's called a whole. Okay, so how are you going to find these wholes? The first thing you're going to do is you're going to factor both the numerator and the denominator of the function. You're going to determine the domain of the function. You're going to cancel any factors that are common to both the numerator and the denominator, and then those canceled terms represent the wholes in the graph. The remaining terms in the denominator now represent your vertical asymptote. Then you can find the y value of the whole by substituting the x value of the whole into the simplified function. Okay, so let's, I want you to pay attention to how you're going to do this. You always want to find your domain first, and that's going to come from even before you canceling out. So after you factor, if you have your factors, you've got your factors like this. Okay, you're going to set the denominator, make it not equal to 0, and figure out what those values are. Okay, that's going to be your domain. Then you're going to cancel. Okay, so if I cancel next, then if I cancel these because they match, well, that value is now a whole. Okay, it's still part of the restricted part of your domain because you're not going to have a point at that number. That's what's going to create a whole, is the function is going to continue up to that point, but then it's going to skip over that point. So it isn't part of your domain. The remaining terms in the denominator are going to represent your vertical asymptote. Okay, so now just this part is equal to your vertical asymptote. Okay, so let's look at a couple of examples of this. All right, so let's take this function. First thing you want to do is you do want to factor. You will always factor first. So when I factor x squared minus 4, that's a difference of squares, so that's going to be x plus 2 times x minus 2. Okay, before you start canceling, go ahead and write down what your domain is. Your domain is setting that denominator not equal to 0. So that's going to be x cannot equal negative 2. Okay? Then you're going to cancel, if you can, any factors. And I can. I can factor x plus 2 times x plus 2. All right, so at this point, we can go ahead and write down the x value of our whole. Your whole will be an ordered pair, so it'll be a point. What canceled is part of the whole, so it's when x equals negative 2. Okay, now, my simplified fraction is now just f of x equals x minus 2. So I'm going to take this x value and I'm going to plug it in here. So this is -2 minus 2, which equals -4. So the -4 is my y value. And that's your whole. Now, there are no vertical asymptotes on this particular function because a vertical asymptote would be if there's any factor that's left in the denominator. And if you look at your simplified fraction right here, this x minus 2 over 1, this is not going to create a vertical asymptote. You would only have a vertical asymptote if you have a variable in the denominator. So you're not going to have a vertical asymptote, so all you have to do is write none. Okay, example 2. Name the restrictions on the domain and the vertical asymptote, but let's also write down any holes that you have. So first you want to factor. Now, if I look at this numerator, I can divide out an x, and then I'll be left with x squared minus 2x minus 3. Okay, now that quadratic, x squared minus 2x minus 3, also factors. So the final factors of the numerator will be x times x minus 3 times x plus 1. Then in the denominator, you can factor out an x, and you'll be left with x plus 2. Okay, so for your domain, before you start canceling, remember you want to do your domain. Okay? I'm trying to make those look like dots, and they don't very well. Okay, so we're going to set this not equal to 0 and this not equal to 0. So our domain's going to be x cannot equal 0 and x cannot equal -2. All right, now go ahead and cancel. So the x's cancel, and that's it. So I end up with x minus 3 over x plus 1 all over x plus 2. Okay, so what canceled is going to be the whole. We know the x value is going to be 0. Okay, but then I want to go ahead and plug in 0 everywhere you see an x. So a 0 will go here, here, and here. So that's going to be -3 times 1, which is -3 over 2. So my whole is going to be at 0, -3 halves. Okay, then the last thing is your vertical asymptote. The vertical asymptote comes from anything that's left in the denominator. So this factor is left in the denominator. So we want to take that x plus 2 and set it equal to 0. So that's going to give me a vertical asymptote of x equals -2. So you can see that x cannot equal -2 because that's going to be the vertical asymptote. But it also can't equal 0 because at x equals 0, there's going to be a hole there. Okay, so what that means is there's just not a point. There's a legitimate hole, like an open circle that's not filled in. All right, on this next example, if you want to take a second and go ahead and try it on your own, and then if you want to press play to check your answers, you can go ahead and do that on this one. All right, go ahead and check your answer. Hopefully you got the factoring correct. Then when you factor, the x's cancel and the x plus 7's cancel. So before I canceled, recognize that your domain is when x can't equal 0 and when x can't equal -7. Because those did factor and cancel, then those are going to create holes. You're going to have a hole when x equals 0 and a hole when x equals -7. So then I plugged those in here to to the simplified rational. Okay, so after I simplified it, I went ahead and plugged in 0, and then I also plugged in -7. So I get the y value when x is 0, y is -7. When x is -7, y is -14. And then because everything canceled in my denominator, then I don't have any vertical asymptote. All right, let's look at this next example. So go ahead and factor it. So if I factor the numerator, I get x plus 2 times x plus 1. The denominator just stays x plus 3. Now notice that there is nothing that cancels here, but I will go ahead and write down what my domain is. First, my domain is x cannot equal -3. Because there's nothing that cancels, for my wholes, there won't be any, so you do need to write down none. And then your vertical asymptotes are going to be x equals -3. Okay, so this last one was a little bit simpler, and that is it for this video. So please understand the order that you need to go in. It's very important. Make sure you've taken good notes on this. Please let me know if you have any questions, and come to class with those written down.